Okay, guys, we're going to start Chapter 4, Factoring and Solving Quadratics. Okay, the first lesson here, we're just going to learn how to factor. There's a couple different ways. Um, Before we get into that, we're just going to review kind of the way to multiply polynomials, whether we're using the FOIL technique, um, which is essentially the distributive property, or some of you are using generic rectangles. Okay, the FOIL means you multiply the first, the two outer ones, the inner ones, and then the last, and then combine like terms. Okay, so the first, x times x is x squared, plus 5x, minus 3x, minus 15, combine like terms, x squared, plus 2x minus 15. Okay, I'm going to show the other one the way some of you maybe used it in 8th grade, where you use generic rectangles. We're going to kind of move away from this approach. There's nothing wrong with it mathematically. It provides a neat graphic organizer. However, I think there's some more efficient ways to do it that we're going to expose you to. So 2x times x is 2x squared, x times negative 1 is negative x, 2x times negative 5 is negative 10x, negative 5 times negative 1 is 5, and then you just combine like terms. 2x squared minus 11x plus 5. Okay, would be your final product. Okay, so essentially what we're doing by factoring is going from this sum back to the product. Okay, same thing, going from this sum back to the product of two terms. Okay, so some essential questions here. What are the methods that can be used to factor, and how can factoring methods be combined to completely factor? And the key word there is completely factor. Okay, while factoring these, it's the process of rewriting a polynomial as a product of its factors. Again, we want our end product to be what expression times what expression. Okay, so we're going to look at one method called the AC method. Okay, because a quadratic is written as ax squared plus bx plus c. Now, the shortcut here, when the coefficient, when this a value is 1, like this first example, okay, all you have to do is figure out what multiplies to be negative 24 but adds to give me positive 10. So you could list out your factors to get 24. So 1 and negative 24, negative 1 and 24. You could do 2 and negative 12, 12 and negative 2. Okay, so actually, not that one. 12 times negative 2 gives you negative 24, but 12 plus negative 2 gives you positive 10. So you put your positive 12 here, your negative 2 there, and then if we were to multiply this back out, it would give us our original sum over here on the left. Okay, some people did this using the box and diamond. Okay, I'm going to show this once, and then we're going to kind of move away from it. Your ax squared term went there, your c term there. The product of these two things that we just put in the box, the ax squared and the c, goes up here. So x squared times negative 24 is negative 24x squared, and then your bx term goes in the bottom. So essentially you're doing the same thing. What multiplies up here to give that, but adds to be down here. So you're solving your diamond problem. Okay, so that would be 12x and negative 2x. Doesn't matter where these things go. Okay, and your other two, and then you figure out the labels for the outside of your rectangle. So x times x is x squared. X times what over here is 12x, so that'd be 12. And then x times what gives you negative 2x, that'd be negative 2. So you still get x minus 2 times x plus 12. Okay, the second example, okay, we'll do in blue. This is actually a difference of squares, okay, because this is a perfect square here. X squared is x by x, and because this is a perfect square here, 16, 4 by 4, and there's subtraction in the middle, okay, what you can do is essentially take the square root of that and put as your first term here in each expression, and then take the square root of that put as your second term, and then you just put an alternating sign, 1 plus, 1 minus. So when you multiply that out, you would get a 4x and a negative 4x, which wipes out your middle term, and you have no b term. Okay, so that's a difference of squares shortcut right there. Okay. Here's a little flow chart that you guys can look at. So the first thing we should always do is try and factor out a GCF, which we're going to see here in the next couple of slides. Okay, if it's a trinomial where the a value is 1, which is here, okay, we can do what we just said here with the AC method, where you figure out what multiplies to give me this, but also adds to give me that. Okay, and you put those terms there and there. When a is not 1, essentially you're doing the same thing, but it's a little trickier, and we'll go over that. 4 terms factoring by grouping, and then up here at the top, the difference of squares, which is the example that we just did. Again, lots of things here that we can do, and then at the end, I think our last slide is going to be sum and difference of perfect cubes, okay, which is a little bit more challenging, but we'll talk about that later. Okay, so looking at this one, types of factoring, we can look at it and figure out what does an 8x squared y and a 12xy have in common. Okay, what is the greatest common factor? Using the generic rectangle approach, again, I'm going to connect to this first, and then we're going to steer away from it. So each of these terms contains a multiple of 4, a multiple of x, and a multiple of y. So if we're doing this times this to get what's in the box, 4 times what is 8, 2, x times what is x squared, x, and then y times 1 is y. So if we would multiply these two things here, we would get that. Okay, same thing with the other side. 4 times what is negative 12, negative 3, x times what is x, we already got it, y times what is already y, we already got it. So your final answer is 4xy times 2x minus 3. So that's the visual representation of it. However, most of us should be able to do that in our head. Okay, here's an example, factoring by grouping, where you're going to be forced to do some of that GCF in your head, pulling out the greatest common factor. When you do factoring by grouping, here because we have a cubic, okay, an x cubed term, we can't use the box and diamond approach. Okay, so if some of you are experts at that, okay, yeah, that's great, that's fine. However, you're going to have to come up with an alternative method. All right, so when we factor by grouping, okay, we're going to group these two terms together, and then we're going to group these two terms together. Okay, I'm actually going to take the sign there, because if that's negative, it presents an issue that you need to take the sign in front. So now, with this term here, we're going to pull the greatest common factor out of that. So 5x cubed and a negative 10x squared both contain a 2x squared. Or, not a 2x squared, 5x squared. Okay, so what remains is x minus 2. So if we were to distribute this back, that gives me 5x cubed, that gives me negative 10x squared. Okay, we're just undoing that. All right, same with the 3x minus 6. What's a 3x and a negative 6 have in common? They each have a 3. So when we lose the factor of 3 from the first term, an x remains. When we lose the factor of 3 from the second term, a negative 2 remains. All right, so now when we look at this, okay, we can still look and kind of use the greatest common factor. What factor does this first term have that the second term has? Well, they each contain an x minus 2. So if we yank out the x minus 2 from each term, okay, pull that out, a 5x squared plus 3 is what remains. That and that is what remains. All right, so our final product, again, it doesn't matter which way you put it, would be 5x squared plus 3 times x minus 2. Commutative property says doesn't matter. All right, so if we were to redistribute all this, okay, we would get our same sum that we started with over here. Okay, and that's one way you can do it. You can check to make sure. We'll do a quick check here just for practice purposes. So 5x squared times x is 5x cubed. 5x squared times negative 2 is negative 10x squared. 3 times x is 3x. And then 3 times negative 2 is negative 6. So we can see that it matches exactly, so we know that this product here that we have is correct. Okay. Here's some more of the when a equals 1, the sum and product. So we look at this and say, you know, what multiplies to give me 5 but adds to give me negative 6. So we can list down our factors. Okay, well, 1 times 5 or negative 1 times negative 5. Well, this is your winner. So put your negative 1, put your negative 5. Here's your answer. Okay. Next one, what multiplies to give me negative 30 but adds to give me 7. Okay, so the products of negative 30 are 1 and negative 30, negative 1 and 30, 2 and negative 15, negative 2 and positive 15, 3 and negative 10, negative 3, positive 10. Lastly, 6 and negative 5, negative 6, positive 5. So one of these options has to add to give me a positive 7. Right there it is. So it'd be x minus 3 times x plus 10. Okay, and that is your product in factored form. All right, now here are some of the ones that are a little bit uncommon, where we're doing the same thing that we did up here using the AC method, except now this a value is not 1. Okay, so you're going to multiply your a times your c to get a negative 6. So we have to figure out what multiplies to give me negative 6 but adds to give me a negative 5. So we can still look at our products here. 1 and negative 6, negative 1, positive 6, 2, negative 3, 3, negative 2. Okay, which one adds to give me negative 5? It's actually the first one. Okay, so let me start over here. So essentially what we're doing is we're taking these two, okay, and we're splitting this term up. So it's 2x squared, and then we can say it's a positive x term because that's positive 1, and then a negative 6x. Okay, so we're splitting our bx term into a 1x and a negative 6x from what I have circled over here on the left. All right, now we do what we did in the previous one. We factor by grouping. All right, so I'm going to group those two together and those two together. So what's a 2x squared and an x have in common? An x. So a 2x plus 1 remains. Okay, what's a negative 6x and a negative 3 have in common? I'm going to pull out a negative 3. Therefore, a 2x plus 1 remains. Okay, and the whole goal of this is to get the same thing out twice. If you don't, you did something wrong. So now, when we pull out the greatest common factor from this term and this term, what do they both have in common? A factor of 2x plus 1. And then what remains? X minus 3. Okay? Let's try another one. Okay, so we're going to multiply a times c. Okay, that gives me negative 12x squared. So what multiplies to give me negative 12 but adds to give me a positive 1? So list your factors of negative 12. 1, negative 12, negative 1, 12, 2, negative 6, negative 2, positive 6, 3, negative 4, or negative 3, positive 4. Okay, and our winner is actually our last one here. So we have 6x squared plus x minus 2. This gets split into negative 3x and 4x. Okay, everything else comes down. And then you factor by grouping. What's a 6x squared and a negative 3x have in common? They both contain a 3x, which leaves a 2x minus 1. What does a 4x and a negative 2 have in common? They each contain a positive 2, which leaves a 2x minus 1. We see our same term here. That's our greatest common factor. We can pull out front, and what remains? 3x plus 2. And there's your factored form. Okay. The difference of squares formula that we talked about before only works if you have two squares, so two perfect squares, and difference means subtraction. Okay, so like I said before, you essentially are just taking the square root of this, putting them here and here, here and here, and then 1 plus 1 minus to get that 0 term in the middle to wipe out. Okay, but this only works if you have two perfect squares. So x squared is a perfect square. The square root of that is x. Square root of 49 is perfect. It's 7. Make 1 plus, 1 minus. Okay. Same thing here. When they look a little crazier or tougher, as long as it's still a perfect square, you can do this. So the square root of 16x to the 4th is 4x squared. The square root of y squared is y. Make one addition, one subtraction. There's your answer. Why that's not working the first time. Okay. Sometimes, even when you do this, you have to just make sure that you still don't have perfect squares. Like this term right here is a perfect square, but that one's not, so we can't do anything else. Okay, but sometimes things can continue to factor even more. Okay. Perfect square trinomials. If we go back up to this slide, perfect square trinomials. Not up there. Okay. Perfect square trinomials is just the same thing times itself. Okay. So if you recognize the shortcut, great. Otherwise, you can just factor it like normal. What multiply, because the a value is 1, what multiplies to be 9, but adds to give me 6. So 1 and 9, or 3 and 3. Well, it's 3 and 3. So you got 3 here, 3 here. And again, it's called perfect square because this is the same thing times itself. So we can rewrite this as x plus 3 quantity squared. Okay. This one here is a little bit tougher. This one's actually going to be 2x plus y times 2x plus y. If we would forward that back out, that's what we would get. Okay. So 2x times 2x is 4x squared. 2x times y is 2xy. We get another 2xy underneath. Y times y is y squared. Okay, and this is the perfect squares trinomials formula. So again, if you recognize, that you have this, great. Otherwise, you're just going to probably factor it as normal. So this is a perfect square, this is a perfect square, and then when you take those a and b values, you double it for the middle because it's the same thing. And then we just have the subtraction down below. Okay, but my experience is most people don't recognize those. Like the difference of squares shortcut, they just factor it and they're like, oh, it's the same thing, so I'm going to write it as x plus 3 quantity squared because it's the same thing twice. Okay, and we just did that one. Okay, here's another one. Because this is a perfect square and this is a perfect square, the square root of this would be 4x. Square root of that. Last term here would be 3y. And if we took 4x times 3y and then doubled it, because that's what our formula says up here, you do 2 times, okay? That's what we got. So Both of these are subtraction. All right. So when you multiply this all back out, you would get a negative 24xy in the middle. All right. Okay. Again, these are kind of rare when they do come up, so I wouldn't put too much emphasis on them. However, I mean, recognize when it does happen. Okay. Here's some practice you can do on your own. We're going to practice a ton of these the next day you're in class. You know, this one's a difference of squares shortcut there. Some of the other ones are just, you know, pretty simple because the a value is 1. This one right here, I do want to do this one. I would not go straight into factoring that because we have a greatest common factor of a 2 hiding inside it. So if there's something we can do to make it easier, definitely pull that greatest common factor out. Okay, now we can continue factoring that. So what multiplies to be negative 18 but adds to give you negative 3? Well, factors of 18 are 1 and 18, 2 and 9, or 3 and 6. In this case, I need a negative 3, so there's our winner. So what I have in brackets here, okay, that will go into x plus 3 times x minus 6, but our 2 also has to come down and follow because that was definitely part of the original. Okay, so if we look down at this one, I don't have a GCF between those 3 terms, so I can't pull anything out front first. Okay, we just have to go straight to factoring it. Okay, some more practice here. This one here has a greatest common factor of x in it. And then look at what we got. I have a difference of squares here. So I'm not done. I gotta continue. So that's x times our difference of squares shortcut, 2 perfect squares with subtraction. So square root of x squared is x. Square root of 9 is 3. Make 1 plus 1 minus. There is your completely factored product. Okay. The next one below it also has a greatest common factor. Okay. You can pull a 2 out of that. Okay. And then continue factoring. Okay. The one down here, that's another difference of squares shortcut, 2 perfect squares with subtraction. So give you guys a chance to practice a couple of them on your own. Again, when you come back for class, we're gonna hammer down on the worksheet and make sure we know what we're doing there. Okay. Here is our last type of factoring, sum and difference of cubes formulas. Okay, so essentially we just have to follow the formula here. Okay, so if I have a perfect cube plus a perfect cube, okay, this is what it boils down to. Okay, if I have a perfect cube minus a perfect cube, okay, then this is the formula I have to follow. Okay, so it's kind of tough because, you know, the first formula here that we're looking at that I've starred, okay, it's the sum of cubes. Okay, we would think everything would be addition, but we do have a subtraction sign here in the middle. All right, same with the other one. Again, it's just making observations. Subtraction, we think everything would be subtraction, but the only thing that's subtraction is that. Okay, so let's try it here for the first one. Okay, we'll keep the formula visible while we work. All right, so the first one is this. We're going to be looking at that highlighted formula because it's subtraction. So if we do the cube root of that, okay, that's going to give us these two things. So the cube root of x cubed is x. All right, and the cube root of 27 is 3. So essentially, x equals x in the formula above, and then the y value in the formula above equals 3. So if I follow that, x minus 3, and then I got x squared plus x times y, so I got 3x. And then y squared is 3 squared, so that's 9. Okay, and that's all we can do. We cannot factor this any further. I don't have 2 things to multiply to be 9 to add to 3. Okay. Here's another example. Okay, this one's addition. So same thing, I'm going to bounce back and forth here. If I take the cube root of each of these, they're perfect. So my x value in my formula is going to be x in this case, and my y value in my formula is going to be 2. Okay, so if we model it, it's going to be x plus y. I'm just copying it down. X squared minus xy plus y squared. Okay, so this is what we have to follow. So we have x plus 2, and then x squared minus 2x plus 4. And once again, I don't have two things to multiply to be 4 and add to negative 2, so this is my final product. Okay. We'll try this one here. This will be our last one. Again, the formula that we're going to model is the one that's highlighted here. Let's see if I can do this. Well, I don't know how to duplicate, so I'm still learning. So I'm just going to copy it down. We'll have x minus y, and then it's x squared plus 2 or plus xy plus y squared. All right, so that's what we have to follow. So if I take the cube root of 64, okay, that's 4, and the cube root of x cubed is x. So that's what x represents in my formula right there. And then y in my formula is going to be the cube root of 27y cubed, which in this case is 3y. So when I do this, okay, I see x here, but x is 4x. Y translates to 3y. Okay, now we have to be cautious here because when I do my x squared, I have to do 4x quantity squared, which translates to 16x squared. Okay, don't just write 4x squared because it's 4x quantity squared. All right, x times y, so that's 4x times 3y, which is 12xy, and then y squared, same thing. Don't write 3y squared like that. It's the quantity 3y squared, which gives us 9y squared. Okay. So there is all the methods of factoring. Okay. You could do, like I said, the box and diamond approach. However, we're trying to, transition away from that. There's nothing wrong with it. It's essentially the same thing. You're still going through your factors to figure out what multiplies to be what and adds to give me what. It's just a graphic organizer approach. Nothing against it. But as you progress, you're going to get better and quicker, and you're going to make the factoring by grouping way more efficient than having to do a graphic organizer each time. Okay, so give some of these a try. As you scroll back up here, if you have questions with some of the U practice stuff, that's where we can open up with class, and then we'll open up the homework assignment and kind of just drill and kill factoring. Okay, thanks a lot, guys.